Okay, so here we have question number 4. This is going to be a challenging one. We have educational psychologists, they do these in psychology a lot, examining response times to on-screen stimulus. The researcher believes there might be a weak effect from age, but expects a more pronounced effect from different color contrast. She decides to examine a black on white combo compared to 2 alternatives, red on white, yellow on blue. Here's the data, blah, blah. They're testing how people respond. This would be for marketing and psychology and stuff. All right, color scheme, black on white, red on white, yellow on blue. And then this is age, like 16 to 17-year-olds, 18 to 19-year-olds, 20 to 21-year-olds. So this is, notice there's 2 factors. This, I'll just call this factor A out here. I guess, well, let me see. Let me actually follow what they did. They did age first. Yeah, so I'll put age first because when I look, I'm just looking down at the questions they're about to ask us and see how they put age first. So I'm just going to make age A. You can do whatever you want, but that'll make it easier. Since they asked age first and then they asked about color, I'm going to make A be the age factor, you see. See how I'm coming up with that? A will be age, how old you are. And then factor B is going to be up here. It's going to be the color scheme. Does certain color schemes make people respond faster to whatever they see on the screen? Factor B is going to be color. Why did I do A on the left, B on the top? Because I just want to make A whatever's first. They happen to ask about age first, so I'm making that A. Okay, so here's the trick. This is easier on something like Google Sheets or software, any kind of Excel or SPSS. It's going to be harder on the TI calculator. Not that hard, though. You can get the hang of it. Let me show you. Here's what you do. You have to enter all this data. And there's a lot of data, by the way. How much data is there here? I don't know. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8, and there's 1, 2, 9 of these. There's 8 times 9, 72. It's going to be a 72 by 3 matrix D array. There's 72 data values. Now, the real trick is getting them in the right spots. How do you do that? Well, factor A, this is going to be 1, 2, and 3. This is a 3 by 3 ANOVA. And then factor B, this is going to be 1, black on white, 2, red on white, 3, yellow on blue. So then just go through and put in the numbers as they sit. This is 1, 1, 1, 2, 2, 2, 3, 3, 3, and then put the other factors. 1, 1, 1, 2, 2, 2, 3, 3, 3. Do y'all see what I'm doing there? These are the numbers that must come in columns 2 and 3 after the data. So for example, let me tell you what I'm going to do. Let me be really clear here. That is my job and my desire. So you're going to go to your calculator. You're going to hit second and the X inverse matrix button. And then you're going to go over twice to edit and down 3 times to matrix D and hit enter, right? I'll show it on the screen again. So you're going to get your calculator on first. Okay, let me clear. All right, so here we go. You're going to hit second matrix, going to go over twice to edit, down to D, hit enter. And then what size? Well, we just said it's going to be 72, enter, 3, enter. You got to set up a 72 by 3 array. 72 by 3. How do I know there's 72 data values there? 9 groups of 8. 72 data values. Hit enter, and then then you got to put in the data. Now, when you put in the data, that's what I'm telling you about. So you're going to type in the data like that. Like let's talk about this group of data, for example. I'm going to type into my calculator in matrix D. I'm going to type 9. Okay, let me do it this way. I'm going to type 9, 25, 22, dot, dot, dot. And that's all going to be 1, 1, 1, 1, 1, 1, dot, 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 dot. And then I'll do this next section. Let me Use a different color for clarity. I'll do this one. Now you might be wondering, can you go down? Oh, sorry, that's not a, let me get rid of this so it's not bothering you. There. You might be wondering, Ms. Tran, can you do this group next? You can. It doesn't really matter. Do whatever group you want. Just type there's columns 2 and 3. So I'm just going to do this one next. Okay. And so what's going to go there? Well, the 35, the 45, etc. And what's going to go after that? 1, 2, 1, 2, 1, 2. Everybody seeing that? Why? Because this is A and this is B. And this is the data that you're putting into matrix D. This is all matrix D. This is the hard part, is getting it into the calculator. This is easier, like I said, on computers with software like SPSS or Google Sheets or Excel. But on the TI calculator, it's a little bit of pain. So you got to type in all this data with a 1, 1 in columns 2, 1 and 2 and 3. And then all this data with a 1, 2, right? And then just keep going. Let me maybe show one more here. All this data with a 1, 3. So I'll do 36, 11, and they'll have 1, 3, 1, 3. 1, 3, etc. Does that make sense? Because it's A is a 1, B is a 3 for that group of data. Okay, and then keep going. Then you can come on down to this next group of data. Here, I'll do another one. Come on down to, say, this group of data. You're going to type it all in. It's going to be 35, 36, etc. And it's going to be what? 2, 1, 2, 1, 2, 1, because it's all, 2, whoops, 2 on the age factor, 1 on the color scheme, etc. Is that making sense? So use that. So I'm telling you columns 2 and 3 in your calculator. Just type all 72 data. Make sure your columns 2 and 3 are accurate. When you're done with all that, so I'll come over here and I'll say enter the data, which is the hard part. And it's hard to get it all right, isn't it? I spent hours. And then hit second mode, quit, once you've got that data in there. The mode quit button. Once you've got it all in there. And then we're going to go to our calculator. So once you got all that done, we go here. I'll leave this so you can see it a little bit. Then we're going to go over here to our calculator. We're going to hit PRGM program. You're going to choose the A1 ANOVA. This program you have to get from me on the calculator using my wire. I have to give it to you. It's not naturally on the TI calculator. It's a special program I have to give to you. A1 ANOVA, hit enter, get that program started. And when you do, you're going to have to choose the random block design, hit enter. Boy, my thing is lagging. Enter, and then you're going to have a screen full of stuff which you don't have to read. Just hit enter again when you get that screen full of stuff. Then it'll say, okay, do you really want to continue? And choose option 2. It'll choose option 2 to continue and say, yep, I really want to continue. Hit enter, and then it'll run and run and run, and it'll finally start giving you some output. And once it gives you output, it's going to give you an F value for A, which goes right there, and a P value. And remember what A is. What is A? Age, right? Age. Oh, it's age. And then next, you'll get an F value for B, and that goes right here. And what was B? B was the color scheme, black, white, and those other color schemes. Now, at this point, your calculator will stop, and you have to hit enter to get it to give you the next 3 answers. And once you hit enter, it'll give you the P value for color, and then it'll go forward and give you the FAB, and which is the interaction, It's like, is it a combo effect of how old the person is and a certain, like, do the 16 to 17-year-olds really like the blue yellow color scheme, for example, some kind of interaction between a certain age group and a certain color scheme? It might be. That's the AB and the p-value that goes with that. We're testing these two factors. What affects response time on a screen? Is it the age? Is it the color scheme? Is it an interaction between the two? Is it all those, or what is it? So once you've done all that, then you'll come down here and try to draw your conclusions. And it's saying, provide conclusions. How about A? How about B? And how about the interaction between A and B? Well, if the p-values are low, right? You just grab those p-values. And I don't remember what my, there's my alpha. My alpha is 0.05. Yours might be different. Mine is right here, 0.05. Find your alpha value. And so these are pretty easy. If the p is below 0.05, then there's an effect. Right? So if the p-value, and then same thing here. So that's the p-value for the first group though, right? That's the p-value for which group? For group A, which is H. And then the next one, you'll do, if the p-value is less than 0.05, there is an effect for group B, which was the color scheme. Okay, so it's color. This one was age. And then finally, you know, if the p-value is less than 0.05, then there's an effect for the AB interaction, which is the color and the age interaction. You would say yes, if that's the case. And so there we go. So the hard part of this one is definitely figuring out the numbers that go in columns 2 and 3. So just write them out in advance. So as you enter your data, you got to know, is it 1, 1 in columns 2 and 3, or 1, 2, or 1, 3, or 2, 1, or 2, 2? Just write them out. Just go 1, 2, 3, 1, 2, 3, and then just fill out the table on that. Questions I can answer on that one?